Nominal rates of interest and discount. Now, when we say that the annual interest rate is I superscript M compounded M times per year, then it's understood that IM is the nominal interest rate. Similarly, when we say that the annual rate of discount is D superscript M compounded M times per year, then D superscript M is the nominal discount rate. The word nominal may or may not be present when we are talking about nominal rates. So the way to recognize that the rate is nominal is to look for the phrase compounded this many times per year. So whether the word nominal is present or not, if it says compounded this many times per year, then that is nominal. Now, if I is the effective annual interest rate and D is the annual effective discount rate, and we are talking about compound interest or discount, then we have these conversion formulas. 1 plus I is equal to 1 plus I superscript M by M whole power M equals 1 minus D superscript M by M whole power negative M equals 1 minus D power negative 1. And the amount function in terms of nominal rates is P 1 plus I superscript M by M whole power MT, or P times 1 minus D superscript M by M whole power negative MT. So let's look at some examples. Find the accumulated value of 300 after 4 years at an annual interest rate of 6% compounded monthly. So M is the number of compoundings per year. And so when it's compounded monthly, then we have 12 compoundings per year since there are 12 months in a year. So in this problem, M is 12, principal is 300, and I superscript 12 would be 6%, 0.06. And T is in years, so T is 4. And so using 9.2, we have A of T equals P. So we are using this first half of 9.4. So A of T equals P, which is 300. 1 plus IM by M, so 1 plus 0.06 by 12, whole power MT. M is 12, T is 4, 12 times 4. So this ends up being 381.15. Let's look at another example. Given a nominal interest rate 6% compounded every 3 years, find equivalent annual interest rate. So remember, M is the number of compoundings per year. And so if it's compounded every 3 years, then it means that 1/3 compounding takes place every year. So in this case, M is equal to 1 over 3. T is 3. T is the number of years. And I superscript 1 over 3 would be the 6%, 0.06. And so once again, we use the first two portions of 9.1, which is 1 plus I is equal to 1 plus IM by M whole power M. So 1 plus I is equal to 1 plus 0.06 divided by 1/3 whole power 1/3. And now this thing evaluates to 1.0567. And when we subtract 1, we get I is equal to 0.0567, which is 5.67%. Now let's look at SOA problem 166. An investor deposits 100 into a bank account at time 0. The bank credits annual nominal interest rate I compounded semi-annually. The total interest amount credited in the 12th year is twice the interest credited in the 5th year. Calculate I. So the first thing to note in this problem is that they are using the symbol I for semi-annual compounding. Now remember, the usual symbol for semi-annual compounding was I superscript 2, but they have the right to use a different symbol. And which is what they are doing in this problem. Okay. So the usual equation 9.2 was AT is equal to P 1 plus I superscript M by M times MT. But as we said, they are using the symbol I instead of I superscript 2. So semi-annual compounding means 2 compoundings a year. So M is 2 in this case. So they are not using I superscript 2. They are forcing us to use the symbol I instead. And therefore, this formula now will have 1 plus I by M power MT instead of I superscript M. And M is 2. P is 100, so it would be 100, 1 plus I by 2 power 2t. Now, the amount of interest earned in the 12th year is A12 minus A11, right? The amount at 12 minus the amount at 11, that gives you how much interest was earned during the 12th year. Similarly, the amount of interest in the 5th year would be A5 minus A4. And we are given that the amount of interest in the 12th year is twice the amount of interest in the 5th year. So A12 minus A11 equals twice of A5 minus A4. And now we just substitute these t values of 12, 11, 5, and 4 in this equation, in this amount equation. So A12 would be 100, 1 plus I by 2 whole power 2 times 12. Similarly, A11. Similarly, this is A5 and this is A4. And that's it. And we have a 2 outside. And now we will simplify. So you see, every term has a factor of 100. So we divide everything by 100 in this equation. And so we are left with 1 plus I by 2 power 24 minus 1 plus I by 2 power 22 equals 2 times 1 plus I by 2 power 10 minus 1 plus I by 2 power 8. So now in these first two terms, we factor out 1 plus I by 2 power 22. So we are left with power 2 minus 1 equals, and again here we factor out the lower power is 1 plus I by 2 power 8, and when you factor out 8 powers, we have 2 powers left out from this one and just a 1 left in the second term. And now you see that this term 1 plus I by 2 square minus 1, the term in the bracket is the same on both sides, so we divide out by it, and we are only left with 1 plus I by 2 power 22 equals 2 times 1 plus I by 2 power 8. And now when we divide both sides by 1 plus I by 2 power 8, so the 8 gets subtracted from the 22 and you're left with power 14. That's equal to 2. Now we take the 14th root of both sides, subtract 1, and multiply by 2. So I comes out to be 0.1015 or 10.15%, which is choice A.